Everyone, in this lecture, we will be learning that how to model and analysis a both in fixed beam. So first click on new project. After that a new window will pop up. Here edit the file name. Here I am writing fixed beam and the length unit should be in meter and the force unit in kilonewton. Now click on next button and finish. Now we have to model the fixed beam. So let us assume the length of the beam is 10 meter. So draw the beam of length 10 meter. So it is in now in isometric view. To see the Z view, click on this icon. So here it is our fixed beam of length of 10 meter. So now our first task is to assign the support. To assign the support, just click on support page and create the fixed supports. To create the fixed support, we have to click on create button and select fixed support and add. So here support number 2 that we have created. Now we have to assign this support to the respective nodes. So as the beam is both in fixed beam, so we have to assign this support number 2 at the both the end. Okay, so now using the node cursor, we'll select both the nodes and select support number 2, and here assign method is assign to selected nodes. Click on assign. So here it is asking that do you want to proceed, and yes. Now close. Now the next step is assign member properties. To assign the member properties, just go to the property page and click on define. So now you have to select the shape of the member. So now here I am considering that the member is rectangle. Now input you have to input here yd and zd. What is yd? It is denoting the depth of the beam, and z is the depth of the beam. So I am considering the size, cross sectional size of the beam is 250 by 250. So as the unit in meter, so here I am inputting in meter, that is 0.25 meter by 0.25 meter, and let us consider the material of the beam is steel. Now click on add button and close. Now we have added the member property. Now our task is we have to assign this member property to the respective member. To assign this member property, click on the beam cursor, select the beam and click select assign to selected beams. Click on assign. So here it is again asking that do you want to proceed. Click on yes button. Okay, now close. So we have assigned the support as well as the member property, and our next task is load application. To apply load, just click on this load page and select load case detail and click on add button. So here the loading type, select the loading type. Here I am selecting the loading type is dead, and the title of the load case is load case 1. So you can edit here. So here I am writing dead load and next click on add button and close. So here for our load case, that is dead load. Now select the dead load and again click on add button. So here I am assuming that the load that is applied on our fixed beam is a UDL load of intensity of 10 kilonewton per meter. So now click on member load and uniform force. Now here we have to input the intensity of load, that is minus 10 kilonewton, that is of minus 10 kilonewton per meter. Why I am inputting minus? Because of the load acting to downwards direction, that's why it is negative. Instead, the downward direction, negative y is downward direction and positive y is upward direction, and the direction should be in global y direction. Now click on add button and close. So here the in red color the question mark is showing, that implies that the added load haven't assigned to the member, so we have to assign this load. So how to assign? Just click on the load. After that, use cursor to assign and click on assign button. Now you can assign the load just clicking on the member. So now we have assigned the UD load of intensity minus 10 kN per meter. Now next step is click on analysis and print. After that, select static change, click on add button, close. Now post print, click on post print. Next define command, just select the load list, click on this arrow button and click on add. Now here we want to see the joint displacement, member force and support reaction. Member force means that is the shear force, bending moment, etc. So now we have to add this output, that is joint displacement, add member force, add, and also the support reaction, add. Next, click on closure. Now we have to assign this print joint displacement, print member force and print support reaction to the respective members and node. So first print joint, select the print joint displacement and select the joints. So here are two joints. So select node cursor. After that, select the joints and click on assign to selected nodes and click assign. After that, pin member force. So here click on beam cursor. After that, select the member. Now assign to selected beam. Click on assign. And next is pin support reaction. So here total two numbers of supports. So select the node cursor and select both the support and click on pin support reaction. Sorry, select the node cursor, select both the supports. Now assign to selected nodes. Click on assign. Yes. So we have done our work. Our final step is analyze. Click on analyze and run analysis. Here the structure have been modified, is asking that do you want to save. So yes, click on save button. So at the bottom you can see that there is 0 errors, 1 warning, 0 nodes. Now click on post processing mode and next click on done. And here the showing that load, that is load dead load 1. Okay, and click on now click on OK button. Now it is in post processing mode. So to see the bending moment diagram, click on moment about z axis, that is mz. So once we click here, the bending moments diagram will appear. So here it is the bending moment diagram. To see the value of maximum bending moment at the fixed support, just click on results. After that, view value and beam results. Now click on this box, that is bendings at the end, maximum and midpoint. Now click on annotate. Once you click here, you can see that the maximum moment bending moment generated at the support, that is 83.33 kilonewton meter, and minimum bending moment generated, not minimum, uh, at the mid point of the beam, the bending moment is 41.667 kilonewton meter. So as you know, the maximum bending moment occurs in case of fixed beam is at the fixed support, that is WL square by 12, and at the midpoint of the beam, the value of bending moment is WL square by 24 if the load is a uniformly distributed load. Okay, so in the same way, if you want to see the shear force diagram, just click on Fy, that is shear force along y direction. Once you click here, the shear force diagram will appear. Okay, to see the shear force value, just follow repeat the previous step, that is click on results. After the view values, click on beam result and shear force and maximum, midpoint, and click on annotate. Okay, so here you can see that the maximum moment is at the ends and minimum moment is at the midpoint, that is of 0 kilonewton. Okay, now click on close button. Next, if you want to check or see the deflection value, mm, just click on deflection. After that, result, uh, view value, beam